Welcome. In this video, we are going to cover inductive arguments. We're also going to go over the difference between a strong and a weak inductive argument, what a cogent inductive argument is, and three versions of inductive arguments, namely enumerative arguments, analogical arguments, and causal arguments. So let us get started. An inductive argument is an argument whose premises do not guarantee the conclusion, but try to make the conclusion probable. What this means is that every inductive argument turns out to be invalid. Because remember, a valid argument is an argument that guarantees its conclusions under the assumption that the premises are true. With an inductive argument, the best that we can do is make the conclusion probable under the assumption that the premises are true. So rather than having valid and invalid arguments with inductive arguments, what we instead have are strong or weak inductive arguments. So what makes an inductive argument strong or weak? Well, the more probable the conclusion, the stronger the argument is. The weaker the conclusion, or the less probable the conclusion, the weaker the inductive argument is. So the way to think about this is that inductive arguments fall somewhere within a spectrum of strong and weak. The more evidence that we have for the probability of a conclusion, the stronger the conclusion is going to be. The less evidence we have for the probability of a conclusion, the weaker the argument is going to be. An inductively cogent argument is an argument that is inductively strong and whose premises are all actually true. Compare this to a sound argument. Remember that a sound argument is an argument that is both valid and all of its premises are actually true. Well, a cogent argument is an argument that is inductively strong and whose premises are all true. So now, consider the following two inductive arguments. Inductive argument 2 here, this should be a 4, premise 4. Inductive argument 2 here is going to be stronger than this inductive argument because it provides more information for the conclusion that Hector probably works at RCC. In addition to that, this argument, given that it's a strong argument, also happens to be cogent because all the information is true. For the remainder of this video, we are going to look at three versions of inductive arguments. We're going to look at enumerative arguments, analogical arguments, or arguments by analogy, and causal arguments. An enumerative argument, or sometimes called a statistical argument, is an argument that starts with observations about some members of a group and ends with a generalization of all the members of the group, or sometimes with a generalization about a particular member of the group. When you look at the video on module number 3, enumerative arguments, you'll see that the individual in that video describes enumerative arguments a little bit different than the way that I'm describing them here, but it really amounts to the same thing. So take this argument here. Most peace activists I know are kind-hearted. We start with an observation of some members of a group, namely the peace activists that I know, and we generalize about all peace activists as being kind-hearted. And we see a similar type of pattern in this second argument here. So most enumerative arguments tend to have this general structure. Of course, it's just a general structure. Not every enumerative argument is going to follow this structure, but you can use it as a template to try to identify enumerative inductive arguments. And so again, with enumerative inductive arguments, we make a finite observation of a group of things as having a particular property, and then we generalize and conclude that every member or all members of that group have that property. Another form of enumerative arguments could be where we identify a specific member of that group, and since most members of that group that we have seen have a particular property, and a particular member is a member of that group, then we can conclude that that member who happens to be part of that group also has that property. And this is what you are going to see in the video enumerative arguments on module number 3. Okay, some important terminology about enumerative arguments. So target groups, sample groups, and relevant properties. Your target group is going to be the collection of individuals in question. So, and these are usually referred to by noun phrases. So all peacemakers, computers, and so on. Your sample group is the group of individuals that you have observed, and the relevant property is the property we are interested in. So looking back at these arguments, for the first argument, the target group is going to be peace activists, the sample group is going to be peace activists I know, and the relevant property is going to be being kind-hearted. Generally speaking, the larger the sample size, the stronger your inductive argument is going to be, and the smaller the sample size, the weaker your inductive argument is going to be. Also, you want your representative sample in your enumerative inductive argument to be representative or resemble the target group. The more your sample size resembles the target group, the stronger your inductive argument is going to be. And the less your sample size resembles the group, the weaker your enumerative inductive argument is going to be. Let us move on to arguments by analogy or analogical arguments. These are arguments that compare two or more things as being similar in a particular respect, and therefore concludes or infers that they must also be similar in some other type of respect or in terms of some other type of feature. Analogical arguments tend to have this general kind of structure. So you start off by comparing two things, A and B. You notice that A and B share properties P1 through Pn, and that thing A has this additional property. So since thing A and B share these properties, thing B must also have the additional property that thing A has. So here are 4 criteria that we tend to use or that we can use to judge whether an analogical argument is strong or weak. You want to make sure that in an analogical argument, the number of relevant similarities between the things that you are comparing is high enough. If it's too low, then your argument is going to turn out to be weak. If you have more similarities, then that makes your argument stronger. Also, when it comes to the number of relevant dissimilarities, right, sometimes there may be one dissimilarity between the things that you are comparing that is significant enough that makes your argument weak. So you want to watch out for those dissimilarities between the things that you are comparing. Again, in every analogical argument or argument by analogy, the things that you are comparing are never going to be exactly alike. So that is already taken for granted. But what you want to make sure is that when you are comparing two things, that the dissimilarities are not significant enough to make your argument weak. In addition, the more things that you compare as being alike, then the stronger your argument by analogy is going to be. The fewer things that you're comparing as being alike, the weaker your argument by analogy is going to be. So the number of instances compared here is going to play a relevant factor in determining whether an analogical argument is strong or weak. Also, you want to make sure that there's diversity amongst the cases that you are comparing. The more diversity there is amongst the cases that you're comparing, while maintaining the relevant similarities the same in all of the cases, will suggest that the similarities that you are discussing are not accidental, and this in turn makes your argument stronger. So if you are comparing cases and there's not a lot of diversity amongst the cases that you are comparing, then this will make your argument weaker. The more diversity there is amongst the cases you are comparing, while maintaining the relevant properties, similarities fixed, then the stronger the inductive argument in question will be. Causal arguments are inductive arguments that contain some kind of causal claim. So for example, Mike throwing the rock at the window was the thing that caused the window to shatter, right? This is a causal claim. Causal arguments are the main type of arguments or the main type of reasoning that is primarily used in the sciences. There are many ways of assessing causal arguments, but one of the primary ways of assessing a causal argument is what's known as Mill's method of inductive inference. For this section, I'm going to direct you to watch the video on Module 3, Mill's method, and also the videos Causation and Correlation. And this concludes our video on inductive arguments.